All right, so we're going to study probability. For most of students, probability is a weak area. The reason is it's not very emphasized in the schools, so you're not going to learn much from school. But it's required for some reason. This is a part of the mathematics you're supposed to learn in middle school. Right, in middle school, you have to learn, algebra, number theory, geometry, probability. Right, but geometry, probability, in school basically focus on algebra and then a little bit geometry. Okay, so that's why we're here. We're trying to learn a little bit more practice. And, the key point is how to count the possibilities and the numbers of ways to do something. Then use the definition of the probability to figure out, okay, what is the probability? Okay, the definition is very simple, in general. Okay. So the denominator is the number of all possible outcomes, okay, without any restriction. Okay. And the numerator will be the number of all design outcomes with the restriction. Okay, so that's the definition. And in some cases, the numerator denominator is not going to be the area, it's not going to be the numbers. Sometimes could be the area, sometimes could be the volume. Okay, and so you cannot say the number of the points in this region. You can only points there. Okay, that's called geometric probability. Okay, when most of problems, you're going to find the two numbers, one for the numerator, one for the denominator, and the ratio is always between 1, 0, and 1. And then we also have two rules you can apply. One is called addition rule, the other one is called the product rule. Okay, so we probably needed that later. I'm going to mention this later. Okay, addition rule and the product rule. Okay. Okay, so let's take a look at the first problem. Okay, the cards are randomly drawn one at a time without replacement. That means you're going to take it out from the box, right? From the standard deck of playing cards, what is the probability expressed as a common fraction that the first three cards chosen are clubs? Okay, clubs. Now, okay, so let's say here's a deck of playing cards. Okay, so we have a total. We have a 52 cards there. They're different. Among them, how many of them are? You have to know this part, right? Among them are 13 clubbers. Okay, that's important. Okay, otherwise you cannot solve the problem. All right, so you're going to pick up one by one, okay, and put it here in the order. Okay, the first one, second one, third one, right? They're coming from here. Okay, so the number of all possible outcomes without any restriction. Okay, so when you pick up the first card, there will be 50 choices, right? Then 51 cards left. The second step, you pick up second card, right? Pick up second card. So it'll be 51 choices. Then there'll be 50 choices, right? So this is we apply the principle of counting. If the whole procedure involves several steps, each step is you have a number of choices. Then the numbers of ways to complete this procedure will be the product of the numbers from each step. So that's why this is going to be 52 times 51 times 50. So this is the total number of outcomes, right, of this class. Now, for the numerate, you are only interested in class, right? And for the same reason, for the clubs, you can only have 13 clubs to choose, okay? Because you want to, in the sequence, you have all of them must be clubs, right? Okay. Then the first choice is, right? So here's 1, 2, 3, right? So the first one, you only select them from 13 clubs, right? And so there's 13 choices, right? And then 12 cards left, 12 choices, then 11 choices, so further 11 choices. So this will be 13 times 12 times 11. So the probability will be the ratio of this. Okay? And then you simplify. Okay, so you know how to simplify, right? Don't multiply this out. Multiply this out. You should fract it. Okay, you should fract it, and like a 13 will be cancelled out. And like 52 is divisible by 13, I think. Yeah, 4 times 13 is going to be 52. Okay, so this is us. So after you simplify it, it's going to be only 11 is left on the top, and then denominator is 850. Okay, so that is answer. Okay. So we have to use the so-called principal counting. Okay, if it involves 7 steps, okay, step 1, step 2, and step 3. So if you have K choices, K2 choices, K3 choices, so the number of ways to complete this procedure with the product of the 3 numbers. Okay, and you have if you have 5 steps and do the same thing. Okay, and n is going to be the number of the all possible outcomes. It's going to be the product of these numbers. Okay, so that's the idea. Take a look at the second problem, and I want to try. I want you to try this. Yeah, and give me the answer privately. Yeah. So the idea is here: select randomly choosing 2 numbers from the set with a replacement. That means this number can be used, okay, over and over again. Okay, what is the probability of the product is greater than 40? So first of all, you have to figure out what product of 2 numbers will be greater than 40. That's it. Then you count them, right? So you can write down two sets of numbers, right? 1, 5, 7, 9, 1, 3, 5, 7, 9. So 1 times 1, 1 times 2, 1 times 3, 1 times 4, you know. So total you are going to have so many products. Then 3 times 1, 3 times 3, 3 times 5. In order to get number greater than 40, I think you have to begin with 5. Because 3 times 9, it's 27. Still a small number, right? 5 5 times 9, 5 times 7 is still less than 40. So 5 times 9, okay, is going to be, yeah, it's also 9 times 5. It's going to be 45, greater than 40. Then you start from 7. 7 times 5 is not good. 7 times 7, yes. 49 greater than 40. Okay. Then 7 times 9 and 9 times 7, of course, is greater than 40. Then you look at the 9, right? Then you look at the 9. 9, okay, you already use it 9 times 5 is already done, 9 times 7 is already included, 9 times 9. Okay, so those are all possible products. Okay, since so you're going to write down 2 digits, okay, and then for each box, the digits can be any of this 5. So the denominator, the number of all possible outcomes, right? You have 1, 2, 3, 4, 5 choices, and the second one is also have 5 choices. So the number of all possible outcomes, you're going to have 5 times 5, 25. Okay? Now, the number of design outcomes, and you can count them, right? And how many of them? 6. Because 5, 9, 9, 5, 2, 7, 7, right? 3, 7, 9, 9, 7, 4, 5, and 6. So total 6. So that's why the probability is being 6 over 25. Okay? For the numerator, we did not use principal counting. We just list all the possible outcomes which satisfy the requirement. Okay? Okay, so let's take a look at the next column. You have a penny, nickel, and dime opposed simultaneously. What is the probability that exactly 2 of the coins show heads when they land? Wow, exactly 2 of it. So that means, in other words, exactly when one of the coins shows tails, right? Then they're late. So you can think of a different way to solve this problem. Right? Can you figure it out? Tell me. So you draw 3 circles, right? So this is 3 circles. No, you have a 3, not 3 circles. Toes, a penny, nickel, and a dime. You have 3 coins, right? 3 coins. Those are 3 coins. Penny, nickel, and dime. Right? And so what is the probability that exactly 2 of the coins shows head? Okay. So you have 3 different, you can line in the order. Actually, you can do one by one. It doesn't matter. Those are the nickel, dime, and penny. Okay, you can only have 1 coin, just flip it over, right? You know, 1 coin toast, and record it. Either H or tail, right? So you can use only 1 coin to do the job. It's the same thing. So what we got here is either the first one, you know, doesn't matter, it's penny or nickel, right? So either H or tail. Right? Then try it again. The second one, either H or tail. Either H or tail, right? And you can do the 3 different coins through on the table, and then count one by one. Then the tail, H, okay. So the denominator, the number of all possible outcomes is going to be for the first coin. You know, you can toast. The coin is toasted one by one, not necessarily simultaneously. If simultaneously you have 3 different coins, right? So you can do that. One user, 1 coin to do the same job. Okay, 1 coin to do the same job. So it would be, so you record the outcome, H tail, right? So each time you have 2 choices. So you get 2 choices and 2 choices. Total, you have, it's 8. Okay. Now you are only interested in the outcomes was one of the coins shows tails, exactly, right? Exactly one of the coins shows tails. Then you will see that among them, right, tail, you know, THH, HTH, and HHT, right? So there'll be only 3 outcomes here. So the probability is going to be 3 over 8. Right? Now, if I change the number of the coins, okay, here's a question. If I change the number of the coins to 10, right, the coins are flipped over for 10 times. What is probability that you get exactly 4 heads and 6 tails? Okay. So if we have 10 coins, in other words, okay, or you can have 1 coin just to toast, you know, flip it for 10 times. It's the same, right? Coin or 10 coins simultaneously toast. So what is the probability you get exactly? Yeah, that would be the slightly different way to do, right? So it's a similar problem, but you cannot just list all of them here, like a HTT, right? So what is a probability? Probability that exactly let's say exactly 4 of the coins show head. Right? Okay, can you do this problem? Yeah, 10 different coins closed simultaneously. I just changed the number, right? From 3 to 10. Then what is the probability that exactly 4 of the coins show heads? Now this is a problem equivalent to you just flip one coin 10 times and you record it, right? And you get exactly 4 heads, 6 tails. This is the same problem, right? Because 10 different coins, you can label them. Coin 1, coin 2, coin 3. So they all drop on the table at the same time, doesn't matter, you know. And coin 1 have you can line up coin 1, coin 2, coin 3, right? Then for each coin, there are 2 possibilities, either tail edge or head. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Any idea? I think as the denominator is easy to figure out. It will be 2 times 2 times 2, 10 times 2 to the 10th power. That's a pretty huge number, right? The numerator is tough. This is equivalent to the committing problem. Okay. For example, coin number 2, coin number 5, coin number 6, coin number 10. They show up. They show the heads when they land. This is equivalent to counting how many committees can be formed if it consists of 4 students selected from the group of 10. So that will be 10 factorial over 4 factorial. 10 minus 4 is 6 factorial. So that will be the answer. Think about it. Okay. So you have 10 students in a row, and if you select the 4th one, select the 6th one, select the last one, select the 9th one. Okay, those are the head. Okay. So how many committees you can get? The order, right? So actually, it's equivalent to there's a formula to count them. Okay, if you select 10 out of if you select 10 out of select 4 out of 10, how many committees you're going to form? And that would be 10 factorial over 4 factorial divided by 6 factorial. We can talk about this formula later. Okay, so yeah. So that is a probability. Okay. All right. Now let's take a look at the next one. Please do it. This is a very common problem. Right, 8 students sitting in a row. Among them are Angelina and Susie. Okay, so you have 8 students. Okay, divide. Okay, and have it chair 1, 2, 3, 4. 1, 2, 3, 4. Angelina and Susie, I think they were my students here in attend my math class in 2007. Oh, that's a long time ago. 2007. I think Angelina is already about 30 years old. Many years ago, she graduated from medical school. Yeah, she's very good. She's the best student from Kama High School that year. She gave a speech. Yeah, and her name is Angela Ma, I think. Yeah, I don't know where Susie. She's very tall girl. Okay, so let's solve this problem. Okay, and now this is in a row, right? 8 seats there, right? So if you so the number of all possible arrangements are all called outcomes. Okay, when you put the 8 students in a row, right? That would be 8 factorial. The reason it's 8 factorial because for the first seat you have 8 students you can choose. For the second seat you only have 7 students you can choose, and for the third seat you have 6 students choose, and so on. Okay, and that's why you get 8 factorial. Okay. Now, how to make sure Angela and Susie, so Angela and Susie sit on the same side. The idea is, you let Angela, okay, Angela select one seat first. Okay, so how many seats she can select? The 8. Okay, so maybe here, maybe there, right? Then you must let Susie to select the seat. Otherwise, if you don't do that, then she probably cannot sit on the same side, right? And so Susie select the second seat, okay? But it must be on the same side, right? That's the first step. Second step, how many seats she can choose. Right now, only 3 left. So that'll be 3. Yeah, 8 choices and the 3 choices. All right, then for the remaining students, you have 6 seats left. That doesn't matter how do you, right? So third 6 students, okay, select 6 seats. Okay, so that will be 6 factorial many choices. Okay, it's the same, right? So then, so the number of design outcomes is going to be 8 times 3 times 6 factorial. Okay, so you have to find a way to design some way to complete this task, right? To assign the seats and make sure Angela and Susie sit on the same side. Now, if the second step you do not let Susie to select the seat, then what happens? If another student select the seat, either on the left hand side or on the right hand side, then if Susie select the seat, the third person select the seat, then they have a trouble. You don't know which side, how many seats are left on the same side of Angela. Okay? So either 3 or 2. So that's why you have to let Susie to select the second seed on the same side, the second in the second step. So the probability is going to be 8 times 3 times 6 factorial, and then that's 8 factorial. Now to simplify this number, and then you get here 6 factorial, 8 is going to be 8 times 7 times 6 factorial. So 6 factorial cancels out, 8 cancels out, that is 3 over 7. Right? So that would be the answer. Right, that would be the answer. All right, so I'm going to, this time I really wanted to do, okay, so yes, that's my problem. All right, so this time I wanted to work out this. Mike will flip a coin 9 times. I already mentioned that earlier. What is the probability of that 2/3 or more of the flips will be hit? All right. So first of all, let's figure out what is 2/3 of 9. Right, 2/3 of 9 is 6. Right. So what you're trying to find out is the probability that you will get 9 heads or 7 heads or 8 heads or 6 heads, right? So if you can figure it out, yeah, so that will be, yeah, you get 6 heads or 7 heads, right? More than 2/3, more than or equal to 2/3, right? And or 8 heads or 9 heads. Yeah. So that 2/3 or more of the flips will be hit. So you have to figure out the probability for each of them and add them together. If you can solve this problem and exactly 6 of them will be hit, then you solve the problem, right? You know how to find the first one, then you get a second one. So when you say it's all and all and all, here we use addition rule. Because they're not shows up at the same time. Okay, if you got 6 heads exactly, then it's not 7 heads, right? Right. So as I said that, if you have a 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So uh, so the numerator has a probability you will get 6 heads, and is going to be, first of all, the denominator, for each of the coin, right? When it's flipped, okay, you can, right? The coins can label it, right? It's kind of 1, 2, 3, 4, 5, 6, 7, 8, 9. And 9 coins, right? And so first coin, second coin, third coin. For each coin, there's 2 options, right? H or tail, H or tail. So total number of outcomes will be 2 to the 9th. But for the numerator, okay, you want to get exactly 9 heads. So you have a 9 student, it's 6 heads. So 9 students, you select 6 students from a committee, right? If those students selected, you get an H, right? So so this is like a number 3, number 4, or number 5, number 7, number 8, number 9, and then number 1, 1, 2, 3, yeah. So total 6. Whatever, right? So 6. If those numbers are called or selected, then you put H. The rest of them you put T on them. Okay. So those numbers outcomes will be 9 factorial over 6 factorial, 6 minus 9, 3 factorial. Okay. And similarly, you can find the probability you get exactly 7 heads. Okay. So the answer will be, first of all, 6 heads, the probability. Then you get 7 heads. Then the probability you get 8 heads. And the last one you get 9 heads, or actually is 1. Okay. And add them together, and you have to simplify. Okay. After simplifying, you will get 130 over 512. Okay. So that will be the answer. Got it? Yeah. So this problem is more complicated than the previous one, like 3 coins. 3 coins, yeah, Michael flip 3 coins 3 times. What is the probability that, right? Exactly one of the pre-flip would hit it, right? Then you don't need to use this complicated formula. You can always solve the problem. All right, let's move on to next one. A ball contains 10 jelly beans, 4 red, okay, 4 red, okay, 1 blue. How many white? 5 white, 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 white. So this is my ball, right? Okay. If you pick 3 jelly beans, yeah, pick up 3 jelly beans from the ball at random and without replacement, what is the probability that exactly 2 will be red? 2 will be red. So step 1, right? Figure out the denominator. That's definitely have to do, right? The denominator is going to be, right? You're going to select the 3 bean, right? And the order doesn't matter, okay? You can pick up 3 bean 1 by 1. Okay, you can also do that, just grab 3. So let's use, let's just take 3 without the order, okay? No order, right? Pick up 3 being at the same time. Yeah. 3 jelly beans at the same time. Okay, so no order. So that means the number of all possible outcomes. Now, those 3 beans are all different. We assume even they are all red 3 beans, but their red beans are different, right? At least they contain different number of, if you use a microscope to look at, right, it's definitely different. So you have one total 10. So that means you just select 3 out of 10 to form a group, right? So there's a formula stand, 10 factorial, 3 factorial, and over 7 factorial. Now we keep using this formula over and over again, right? All right, so now you are going to select, you're going to make sure 2 of them are red. Other one of them is either blue or white, right? So now we look at the number of design outcomes. Right? So the number of design outcomes, okay, and then either 2 of them are red, 1 of them a different color. So you can pick up 2 red ones first, then you pick up the other one, okay, because the order doesn't matter. That's the reason when you put in your hands, you can always separate them 2 groups. Group 1, 2 red, group 2, 1 non-red. So that's why, so first of all, in order to pick up 2 red ones, and no order, so out of 4, so that'd be 4 factorial, 2 factorial, 2 factorial, divided by. Then you pick up one, you pick a non-red one. There are how many non-red ones there? Total 6. So that's a 6. Okay. So the left side 2 red, the right hand side just a 6. There are 6 choices. Total, you have this many. Okay, total you have this many choices. Now let's simplify 4 factorial. You have to use a product here, right? Right? You can step 1, you can pick up, you can pick up step 1, you can withdraw 2 red beans. So you have 2 red beans, 2 times 3 times 4, 2 times 2, let's cancel out, that's actually 6, right? So that would be 36, okay? And then step 2, you draw, you pick a non-red bean from the board, and there'll be 6 choices. That's what 6, total 36. Then the probability is going to be 36 over, that number is 120, so 120. Okay? And after simplifying, it will be 3 over 10. Okay. Let me repeat again. So first of all, you pick 3 jelly beans at the same time. So you have the standard formula. Okay. You put in your hands, and they're all different, but the order doesn't matter. Right? So you have a 10 factor over 3 factor, 7 factor, it's 120. Then you only consider the outcomes 2 red beans, 1 non-red beans. But when you're in your hands, you can think about how can I get this. You pick 2 red beans first, right? Right. So the total number of outcomes will be 6. 4 factorial over 2 factorial over 2 factorial. Then you pick a non-red bean, which you have 6 choices. Okay, but this procedure is independent. These 2 steps are independent. So the total number of of a design outcomes will be 6 times 6. The number of the choices from first step times the number of the number of the choices from the second step. Okay. So that's why 6 times 6, not 6 plus 6. Okay, so the second part, then the ratio will be the probability. But our next problem is if 10 letters in mass count are arranged at random, what is the probability that the word match will spread out anywhere in the arrangement? Okay, so what kind of mass count, mass spread out, right? M-A-T-C-H, right? So M-A-T-H-C, M-A-T-C-H, yeah, C-U-N-T-S, right? This is one of the cases, but this can be any position, anywhere, okay? It could be O-U-N-T-S, M-A-T-C-H, it's here. Okay. Right, so step 1, you figure out the number of all possible outcomes. Okay, the number of possible outcomes. This is counting technique. Okay, how many letters there are? 10 letters. How many letters are identical? I think that's 2t identical. That's it. So that will be 10 factorial over 2 factorial. Okay. Right? Then you have to look at how many possible locations for MATCH. I think you have 6 positions you can choose, right? One is here, and yeah. So this is the first position, second, right? 1, 2, 3, 4, 5. So you can put it here, you can put it here, right? If we occupy this space, then you have a 6. You have a 1, 2, 5, 6, 5 left. Okay, so I think you total have a. You totally have a. I think you have a. Yeah, you have a 6. Yeah, you have 6 different locations for match. Okay, once you choose a location, okay, match is already there, and you have a 5 seats left, 5 positions right left for 5 letters. The remaining letters are all different, O-U-N-T-S. So that's why you have a 5 factorial, 5 factorial, 5 factorial in each pattern. In each pattern, you have 5 factorial, many different possible arrangements. Okay, so the number of designed outcomes will be 6 times 5 factorial. So how do you get 6 times? So step 1, you select one of the position, okay, yes, for match, and you have 6. Then once the position for match is selected, then you have 5 letters you can arrange, which is 5 factorial, many different arrangements. So that is outcome. That's the number of options at second step. So the product will be the number of desired outcomes. So once you figure out that, then the answer will be 6 times 5 factorial and 10 factorial over 2 factorial. Now let's figure it out. 6 factorial, 6 times 5 factorial is just 6 factorial. 10 factorial and that's 2 times 3 times 4 times 5 and 6 factorial, right? No, sorry. That's my opposite. Yeah, it'll be 6 factorial. 6 factorial, 7 times 8 times 9 times 10, and divide by 2. So 6 factorial is canceled out, and 10 divided by 2 is 5, so it's 5 times 7 times 8 times 9. So this is a very small number. And you can use a calculator to multiply this out, and that will be 2,500 times 20. Right, this is a very small possibility. All right, we're not able to complete all the problems. All right, so let's, I'm not going to, yeah, let me show you all again. So a bag contains 7 white, 9 blue, and 4 red marbles. If the 3 marbles are pulled up from the bag, what is the probability that 2 are blue and 1 red? I think this will be the similar problems like we did before here, right? So we want 2 blue, 1 red. That's our design outcomes, right? And so the number of all possible outcomes, okay, that will be, and you have a total is 20. Then you take 3 out, 3 factorial, and then 20 minus 3 will be 17. Okay. Then, in order to get these outcomes, step 1, you grab the number of design outcomes. Okay. You want to you can pick up 2 blue, 2 blue one, and 1 red one, right? Step 1, step 2. Got 2 independent steps. Each step, what do you got, right? The number of options for the first step, right? And you have a 9 blues there, and you take 2. So this is this many numbers. Step 2, you have 4 red ones. You only select 1, right? That's 4 choices. Total, you multiply this out, okay? So that is the total number of these outcomes. So the probability is going to be the ratio of those numbers. Okay. Now you have to simplify it. Okay. You have to simplify it. After you simplify it, you can get 12 over 95. Okay. Yeah. Just step by step. Be careful to simplify. All right. Well, let's move on to the next problem. Flip a fair coin. If it lands head, write down H, and the turn is done. If it lands tails, then flip it again, write down H. If it lands head, or T if it lands tails. And the turn is done. Okay, after 5 turns, what is the probability of the 5 H's has been written? Now, be careful about this. Okay, we have to understand the procedure here. So you're going to flip a coin, okay? You may get an H, you may get a tail. right? So what is the probability to get H is 1/2. What is the probability to get tails is 1/2. Now it says that if it lands H, the 10 is over, okay, over. But if it lands tail, then flip it over again, right? And you write down H. If you get, yeah, if it lands head, you write down T if it lands tails, and the turn is then the turn is done. So done in either case. Okay. So this is just one, one. So this is first of all, let's figure it out. Yeah, this is a game result, right? So each time the probability you're getting getting heads, you can figure it out. Okay. So in this case, the probability, okay, of getting heads for each term, okay, is going to be 1/2. This is you have to apply, this is a tree, okay? So either get this or get that, right? So the probability will be you apply the addition rule here, then the product rule. Okay, in order to get the H along the second pass, the probability is 1/2 times 1/2. So total will be 3/4. Okay, so for each term, the chance you get H is given 3/4, the probability. Now, after 5 terms, what is the probability that 5H has been written? So you have to continuously write down, H, right? So this is this then applies the product rule, because each time you get H is going to be 3/4, right? So the probability will be 3/4 times 3/4 times 3/4 times 3/4 times 3/4. Okay, so that is a probability that you always get 5H for 5 times. Okay, the first time you get H, the second time you get H, then total when you multiply this out, this is a probability. Okay. Just like, what is the probability you're going to have a rain on Monday, and the probability is 3/4. Then the probability to have a rain on Tuesday is also 3/4. So, and so on. So what is the probability that every day there will be rain in that week, 5 days, right? So then you have to multiply them out, okay? And that number is getting smaller and smaller, because you have to guarantee every right? You have to guarantee every day there was a rain, so it's a problem not. Right? I do not have too much time, but let's finish the last one. And this is 2 girls, 3 boys set in a 5-seat row at the movie theater. What is the probability that 2 people at each end of the room were both boys or both girls? Express your answer. Right. Right. To solve this problem, you have to, first of all, right, the number of all possible outcomes, because there are 5 seats, 5 students there, will be 5 factorial. Okay? Now you have to figure out the 2 patterns, either 2 boys or 2 girls at the 2 end, either 2. So you have to figure out the number of possibilities, right, for each pattern. Now for the one on the left side, right, for this one, for this pattern, 2 boys at the 2 end seats, right? Then the number of designed outcomes, okay, for this pattern. How do you make arrangement? You select 1 boy, put on the left, there'll be 3 choices. Then you select the second boy and put on the right side, right end, and you have 2 choices because you only have 3 boys there. Okay. Then for remaining 3 students, you can randomly select and arrange the seats for them, which is 3 factorial. And for this pattern, the slide different, and you only have 2 girls left, or 2 girls. You select one of the girl, put on the left, then select the remaining girl, put on the right hand side. So it's only 1 choice. And then there's 3 students left, which is all boys right, and then can be sit in the middle of the random. So there'll be 3 factorial many possibilities. So the probability will be 3 times 2 times 3 factorial, 2 times 1 times 3 factorial, and here divided by 5 factorial, okay? And which is going to be 2 over 5, okay? So that's it, and we ran out of time, and I probably, yeah, we will continue to study probability in the next 2 classes. Okay. Now, if you have any questions about probability when you do the homework, send the email to me in advance so I can discuss in the next class. Okay.